Hey y'all, today we're going to be starting a new unit and it's all about functions. So today's lesson question is specifically, what is a function? And hopefully by the end of today's lesson you'll be able to answer that confidently. So briefly said, a function is any relation where each input has exactly one output. And we'll go through some examples of what is function, what isn't a function. But really we want to just be able to understand what is a function so that later on we can examine different kinds of functions and see how functions operate and all that kind of stuff. So what we want to do is be able to understand functional relationships. And that means we want to be able to define a function in terms of its input and output. We want to know what is the independent variable and what's the dependent variable. And that's kind of what I mean by input and output. We want to be able to identify both the domain and range of a relation. So we'll talk about that more later. We haven't really talked about domain and range yet, and so that's going to come up shortly. Finally, we want to determine whether or not a relation is a function. So a relation is just any relationship between two variables. A function is a specific kind of relation where each input has exactly one output. So let's go through some of these words that I'm using up here a little bit more in detail. We're going to define some of these. And the first thing is a function. So these are kind of in a weird order. So I'm just going to kind of go through them as I feel like maybe it's more appropriate. So a function is a relation which each element of the domain is mapped to exactly one element of the range. So when I use the terms domain and range, what I'm really referring to are your inputs and your outputs. So oftentimes when we write equations, our inputs are represented by the x variable and our outputs are represented by the y variable. We oftentimes will call the variable that represents the inputs the independent variable, and the variable that represents the outputs is typically known as the dependent variable. So let's kind of work through all those. The domain is like a group of values, okay? So the domain is just the set of input values for which the function is defined. The range is the set of all of the output values. So basically any valid output that the function has, if you group all of those potential outputs, that is the range. So the domain is the inputs, and usually that's your x, although I don't want to lock us into thinking it's just x because it doesn't have to be. Like for instance, if we're talking about comparing distance and time, we may use t as our variable, our independent variable, and d as our dependent variable. So it's not necessarily going to be x, but most commonly it is. The range is the list of all the y values. Okay. So let's talk about independent and dependent variables for just a second. All of the values in your domain, like I said, those are going to consist of your input values. And I'm going to move this up a little bit because, like I said, this is kind of a funky order to put these definitions in. But so our independent variable is the variable in a function that represents the input values. All right. In other words, it's like the first coordinate. If you see a coordinate with an x and a y, it's that first coordinate. So the independent variable is likely going to be x. It doesn't have to be. This is a variable, so it could really have any name, but usually it's x. The dependent variable. Let's kind of go back up here. Again, weird order here, but the dependent variable is the variable in the function that represents the output values. It's the second coordinate. So if you have a point that's labeled as like 1, 2, the 1 is referring to the independent variable and the 2 is the dependent variable. So it's a good idea to kind of associate this. Again, it's not always going to be y, but typically it is. So if we have a set of ordered pairs, which is another way of just saying like you have a table or some defined relationship between two variables, that is what we call a relation. So any relationship between two variables is a relation And then some relations are considered functions. A functional relationship is one where each input has exactly one output. So if you input some value into x, the output is going to be uniquely defined, meaning there's just one possibility for that output. So let's look at a table of values and think about these inputs and outputs. Let's say we have this equation y equals 5 plus 3x, and I want to generate a table with my inputs and my outputs. So if I put negative 2 into this equation, let's find what the output would be. Okay, it's listed over here, but usually I would just go ahead and throw this in the calculator and say, okay, well 5 plus 3 times, let me clear this out, so 5 plus 3 times negative 2, and my output is going to be negative 1. Okay, if x is 0, if we plug that in, 5 plus 3 times 0 is going to be 5. So notice I'm generating this list of inputs and outputs. Also take notice that each of these inputs should only have one number. Like if I plug in any number into here, I should not expect to get two different values for y. That really wouldn't make a whole lot of sense, right? Like no matter what number I put in here, I'm just going to calculate this, and whatever that evaluates to be, that's going to be my y value, or my singular output. If I input 1, I'm going to get 8, and if I input something, I'm going to get 11. So if I want to figure out which input gives me an output of 11, I can't just essentially I'm going to do what I did over here, which is to plug it in, but I have to plug that in into y. I've got to substitute 11 for y, and that would look like this. So you might notice, okay, well if I'm looking at this, this looks like an equation I'm going to have to solve. So I'm going to subtract 5 from both sides, and that gives me 6 equals 3x, and then I'll divide both sides by 3. So all of those steps that we learned about in Unit 1 and Unit 2 as far as solving equations, that's going to be useful if we know what the output is and we're trying to find the input. You can, when these numbers are kind of small, you can definitely try to guess and check your way through it. If I just say, okay, well I think if I plug in like 4 in here and then calculate that out, see what it equals, and adjust from there, and you can find it that way. But guessing and checking is not really a great way to do that because this number may not be a whole number. So like if the input is supposed to be like 1.63, what are the odds that you're going to happen to guess that? Probably not very good. So it's better to use this algebraic method to try to figure out what that input value is meant to be. So let's talk about independent and dependent variables. Okay, the independent variable represents the input values. Okay, is usually x. Okay, so independent is usually x, dependent is usually y. And the dependent variable represents the output values. So you've got like these associations you should be making, right? X, domain, input, independent. You should start to associate all these words together. They don't exactly mean exactly the same thing, but they are related. Okay, so you want to just mentally start to group these terms together. With y, that has to do with the range or your outputs or your dependent variable. And again, don't lock yourself down to just thinking these are x and y. Like in this case, for instance, like I was referring before, we've got distance and time, where the time is going to be your input. That's going to basically relate to this column, and then your distance is going to be your output. So usually your input is going to be that variable that is in the expression that is not simplified, and then whatever variable has been isolated on one side of the equation, that's going to be your dependent variable, usually. So this is going to be our independent column. This is going to be our dependent column. These are my independent values, dependent values. This is my domain. This is my range. this is my inputs, and this is my outputs. Okay, so we'll go through all that. One thing, oh, well, yeah, let's go ahead and fill out the table first. If we know that the equation is d equals 54t, then what we can do is just substitute these values into t to calculate the distance. So there's two ways you can approach this. One is just to go through and just type them all in. So like 54 times 1, 54 times, what was the next one? 3, and so on. So you could do that. If this table is, starts to get kind of long, or this equation is a little bit more complicated than this, there is a more efficient way of obtaining these values through the table function in your calculator. So the way you do that is you're going to hit y equals, let's clear out what's in there, and then we'll type in this equation up here, and we're going to use y to represent d and x to represent 54. So I'm going to say 54x. So I'm going to type in 54, and then this button right here is going to be your independent variable button. So 54x, and then to get to the table, notice it's in blue here, so I'm going to hit the second button first, second graph to get to the table, and you'll see my settings are kind of messed up here. These are a bunch of random values in here. Let me clear that out. So if I need to fix that, the way to fix that is going to be, yours might look okay right now. If you haven't messed with your table settings, then you probably are going to see exactly what you need to find over here. But if your numbers are like mine and you've used this before, you might want to reset this. So to do that, I hit second window and then change the independent variable to automatically generate. So in other words, that's going to just automatically pick all of those integer values rather than asking me what independent values I'm interested in. Now this ask function can be useful, like if this table's all over the place, or the numbers are really big, or you have decimals or something, then you probably want to go over here to ask, and then you can just type in whatever numbers you want. But automatically is going to work for us here. Okay, so let's go ahead and scroll down until we get to the values that we're interested in. We've got 0, 0, we've got 154, and just checking to make sure this is right, 2, 108, 3, 162, and 4, 216 checks out. So we haven't really talked too much about domain and range yet, or trying to define that, and this particular page doesn't actually ask for that, but as we kind of move forward, I'm going to continue to ask you like what the domain and range is. So in this particular problem, the domain here of this table is just the values that you see in your input column. So if it asks you what's the domain of this table, you would just write out the numbers 0, 1, 2, 3, 4, and then usually what you'll see are these little squiggly brackets or braces to say, okay, this group of values represents the domain, or is the domain rather. The range is going to be the list of all the possible outputs. So assuming that this is the only data we have, the range here is going to be 0, 54, 108, 162, and 216. Now, there is another way to write domain and range if all we have is this equation. The domain and range will be written a little differently because you could have like 0.5 and all that other stuff. But if all you have is the table to work from, then this is how you write the domain and range. I'll show you later how to write it otherwise if you do have a continuous set of data rather than a discrete set of data. So let's get into that. Okay, the domain is all the input values, and the range is all the output values. So we just got done talking about that briefly. There is another way to kind of think about this. Now, I showed you how to write the domain and range if all you have is the table. But in this is the same problem, but we're actually going to use the context of the problem to help us determine what the domain and range are. So the domain is the list of all your input values. So what I was kind of alluding to before is that you could have like a time of like half a second or 9/10 of a second. This is considered a continuous set of data here because you can't get from 1 second to 2 seconds without or I'm sorry, 1 hour to 2 hours without hitting every single hour in between. All those decimals, like 1.1, 1.2, 1.23, 1.67, like all of those have to be included. And so there's no way to list all of those out because there's infinitely many values there between 0 and 4. So the way to write that is going to be here. Okay, now this already has it kind of labeled here for you, but basically the way you do it is you put your independent, I'll kind of write it out to the side and explain how you write this without having this little fill in the blank stuff. But you're going to write your variable, and you're going to say that that variable is in between the minimum and maximum. So if I look at this table, the minimum is 0 and the maximum is 4. So basically the way you read this is the domain consists of t values such that t is in between 0 and 4. Similarly, the d values, which make up the range, there's all the d values in between 0 and 216. So this is another way, and you'd write it like this basically. This is just another way of writing domain and range, and we'll see some examples hopefully down the line where we have to determine whether we want to write it like this or like this. Okay, so these are like two different ways of writing the domain and range. We're going to use this if all we have is a set of values and we have no context around it, so we can't assume that the numbers in between are included as well. But if we do have enough context to determine that the situation is continuous, meaning every value in between the minimum and maximum counts, then we have to write it like this because it's just impossible to write 1.1, 1.2, 1.3, 1.33, and all those. If we're trying to determine the domain and range from a graph, the domain consists of all the inputs. So if I look at this continuous graph, this is a function, then what we're doing is we're saying, okay, well, all the t values are going to be in between 0 and 90. Notice every single value in between is accounted for too. It may appear that you only have 4 points on this graph if you're not looking closely, and you might be tempted to just write out those 4 points, 0, 30, 60, and 90. But because the points are connected with these segments, you have to assume that this is a continuous situation, so we do want to include all the little points that go along here, right? And so since there are infinitely many of those, we can't just list them out, and so we have to use this this inequality notation to write it. Basically what we're doing is we're writing an interval that's saying that all the t values are in between the minimum and maximum. So that would go in between 0 and 90. You'll do something similar to find the range, except we're looking at the dependent values, meaning the vertical axis here. So all my values are going to go between here and here, right? So that would be between 0 and 21,000. One strategy that you can use if you're having trouble determining the domain and range is to draw a rectangle around your graph so that the edges of the graph determine the size of the rectangle. And what I mean by that is, like if I draw a box around this graph like this, sometimes doing that can kind of help you determine the domain and range. The graph is completely enclosed in this box, and you can see that the minimum and maximum for my independent go from 0 to 90. The dependent minimum and maximum go from 0 to 21,000. So either way you want to kind of approach that is fine, but you do want to make sure that you understand that the domain is going along your horizontal axis and the range is going along your vertical axis. So this is an example of like a table coming from an equation. Here's an example of a graph. But there's something else that we haven't really talked much about, and that is a mapping diagram. So a mapping diagram is really just like a table, okay? It's just sometimes the table's going to be mixed up, and these arrows show you which inputs are matched up with each outputs. So this particular one is just showing that, hey, these are just aligned horizontally. So this is really no different than a table. But if, let's say, -4 outputted -2, you might see like an arrow pointing like that. to notate that. Now in this case, that doesn't happen, but the advantage to the mapping diagram is you don't have to write repeated values. You can just just write it once. Like if -4, -2 is a point, and 7, -2 is a point, you wouldn't have to write the -2 twice. You would just draw an arrow from the input to the output. All the numbers in this first oval for these input values, that is my domain, and this is my range. So this is a case where we don't have any extra context to determine whether or not the values in between should be included, so we can't assume that they should be. So this is going to be a case where we just simply write the values rather than list the minimum and maximum. So the domain here is just going to be all these numbers, -4, 0, 1, and 7. And the range is going to consist of, and it looks like they're going in numerical order down here, -2, 1, 3, and 5. So the big takeaway from that is that your domain consists of your x values and the range consists of your y values. But let's dive back into what a function is, because that really is the question for the day. It is important that you understand what domain and range means before we can really tackle this idea of what a function is. But let's go ahead and do that since we've already talked about domain and range. So in a function, each value for the independent variable maps to exactly one value for the dependent variable. So this is that same situation that we had before, our good friend Isaac taking this 216-mile trip. You probably recognize this table, okay? Now, let's analyze what it means to be a function, okay? So a function is defined as any relationship where each input has exactly one output. And this does represent a function because each input has exactly one output. For each given time that you could come up with, you could plug that in here and then get some distance out. And what makes it a function is that you don't get two different distances out. So like if I plug in 2, I'm not expecting to get two different numbers here, just one, whatever 2 times 54 is, which happens to be 108. So this definitely will be a function, okay? In this case, for any given time, there's exactly one given distance. So you would say that Isaac's distance is a function of time. And that's just how you would describe that situation. But let's talk about, like, how do we tell at a glance, whether or not something's a function. So in order for it to be a function, again, each element in the domain has to correspond to exactly one element in the range. Each input has to have exactly one output. So that's the only question you're trying to answer if you're trying to determine if it's a function or not a function. Okay, so this is an example of a function. Notice each element in the domain corresponds to exactly one element in the range. It is okay if two different inputs give the same output. That does not prevent it from being a function. The only thing that you have to satisfy is that each input basically has one arrow running away from it. So each element in the domain has only one output. So this would be a function. Now this is not a function because you'll notice 3 has 2 different outputs. You've got 2 different arrows coming out from number 3. 3 has an output of 4, meaning like there's a coordinate on the graph 3, 4, but there's also a coordinate 3, -5. If I try to envision that real quick, here's 3, 4 is here, and then 3, -5 would be somewhere down here. Right? This input of 3 has 2 different outputs, and so that prevents it from being a function by definition. So 3 has an output of 4, but it also corresponds to -5. Since you have an input, and it only takes one to prevent it from being a function. If you have one input that has 2 different outputs, then this is not a function. So let's take a quick look at this. Is this a function? Without even knowing what those other values are, you can tell right away, boom, yes, this is a function. Each element in the domain only goes to one element in the range. Okay, -8 will go to 0, and we know that because we've got a point -8, 0. We've got a point 3, 5, 4, 4. That's coming from right here. 5, -2. It's coming from right here. And finally, 9, -1. So this is absolutely a function. Now, hopefully at this point you understand how to determine if you have a function, if you have a mapping diagram or a table or like a list of ordered pairs. But there is a shortcut to determining whether or not something's a function if you're given a graph. Let me go back to the first function, or this first page about determining whether or not it's a function. We said this one was not a function because you had one input, +3, going to two different outputs, right? 4 and -5. Well, what you'll notice is that when that happens, you have 2 points that are vertically aligned. In other words, if I can draw a vertical line and it will pass through both of them. So if you ever have a graph where you could draw a vertical line and it passes through that graph more than once, then it's not a function. And the reason for that is because what's being indicated is that a single input has multiple outputs. So this visual test to determine if a graph is a function is called the vertical line test. And basically what it says is if you can draw a vertical line that and it passes through the graph more than once, then it's not a function. But if you look at these two graphs, so like this one, it looks a little squiggly, but at no point could you draw a vertical line. I could draw a few more, 2 are drawn here, but I could draw some more. But any vertical line I draw is only going to hit that graph once, so we say absolutely that's a function. Versus a graph like this. I could draw a vertical line in many places and it would pass through the graph more than one time. So whatever input this is going to have more than one output. So this is not a function. There are a few places here, like over here, you notice if I draw a vertical line going right through the vertex of this parabola, it's only going to hit it once. So that doesn't prevent it from being a function, but you only need one failure of the vertical line test to say that it's not a function. So let's sum up here. What is a function? So a function is any relation where each input has exactly one output. And that's what a function is. So just to recap here, we've talked about what a function is. We've talked about a lot of different vocabulary terms referring to the inputs and outputs. So you've got your inputs, you've got domain, you've got your x values, your independent values, and on the other hand, your outputs are associated with range, the y values, the dependent variable, and then we started talking about functions and discussed what is a function, what isn't a function. So that's all for today. Next time what we'll do is we will look at a specific type of function called a linear function, and it's not really that bad. You've actually talked a lot about linear functions probably in 8th grade, and you've already solved a bunch of linear equations earlier this year. So that's it for today. Y'all have a great day, and good luck on your daily quiz.